Okay, our last speaker of the day is Chagnon from Worcester Polytechnic Institute, whose session title is a little bit cryptic. It's simply Code for the Codeless. So I'm looking forward to hearing what Chris has to say today. Chris, are you on the line?
Yes, I am. Can you hear me fine?
Yes, we can hear you.
All right, and I will even share my screen for everyone. Good afternoon. All right. So to get right into it, because we do have a limited time here and I do want to leave some time for some feedback and questions, this is a session called Code for the Codeless. My name is Chris Chagnon. I'm an IT Service Management Architect at Worcester Polytechnic Institute, but probably not the Worcester or Worcester that you're all familiar with. But I do want to get into this. So when I talk about Code for the Codeless, what we've heard from our vendors as we've switched to ITSM solutions is that no code, low code, codeless, or codeless are these big trends and a million other marketing terms. Really awesome things that people are doing there, but not necessarily something that means anything, right? So when we think about codeless or low code, what we probably mean is a lot of menus, a lot of editors, a lot of different settings and things that you didn't know how they'll work, and they're different between vendors, different between applications. But with that, there comes a degree of needing to kind of understand some coding concepts. I know that that's contradictory to say you need to know coding to do your low code or no code settings, but when you consider what these platforms can do, it's very easy to dig yourself into a hole or paint yourself into a corner because of some choices you've made early on. So what I'm going to cover today is some concepts from coding without getting too much into coding. I don't want to overwhelm people, or I don't want to bore people who already know coding concepts, but these are kind of my thoughts and musings on good things to know, even if you're working in a no-code environment. So to get right into it, immutability. This sounds scary. It's a weird term, it's very technical, it's very jargony, but what does immutability mean? So if something is immutable, what we're saying is that it has an unchanging nature, which is still kind of not a good definition, right? So it means that it's the least likely to change, a little better. But really what we mean is unique IDs or GUIDs or other things you know won't change. So it's easy to talk about which things won't change, but more likely let's talk about the things that do change that don't help us out too much. So people's full names, first names, last names, email addresses, sometimes even employee badge numbers, the name of their PC or workstation, those are things that can change. So if you're setting up a system and you've made it so that everything is looked up by somebody's name, that could be a dangerous choice to make early on. So the reason to think about this concept of immutability is because I've seen time and time again people going into their systems and saying, well, yeah, let's set this up. It lets us set up tables and things like that. So even though it's no code, we still have some of those database concepts going on, but we didn't set up an ID column or we didn't set up things like that. And all we do is look up by name. So everybody's tickets are in the system and they're entered by their name and there's no ID number. Then all of a sudden their name changes. They're locked out of the system. Their tickets can't be looked up. All of their tickets go under a new name. It sounds weird that the systems would let you do that, but if it's not something you think about, it's very easy to accidentally do it. You're probably not going to see this with some of the main concepts like tickets, but as you extend out these systems with these low code environments, it is very easy to accidentally do this type of thing. The next concept to cover here is called staying dry or dry, which means don't repeat yourself. In coding, what this means is write a lot of reusable code over and over again. That means that you're writing things like functions or methods in a way that you can keep reusing them and they have clean inputs and things like that. It doesn't really fit for the no code world because you're not writing any code that you can reuse. But where I try to extend this to the no code world is start thinking about the grand scheme of things or a bigger picture. So if you think about the user experience or the customer journey, which again are dangerous words to start going down, but really important that you do consider with these platforms, start thinking about how these things extend, how you can use things over and over and repeat using them or different aspects of it. Put more simply, think about a simple form that you're making in your IT service management system. Let's say you've gone through the process of making a system or a form that allows people to request laptops. Some people might then make another form for requesting desktops, for requesting cell phones, for requesting all these different devices. but those are probably going to be very similar. So if you then just try to make a procurement form that lets people choose which type of thing, laptops, desktops, if they're all going to be very similar, coming up with a grander system here is going to help you out. So this way you don't have to maintain all those separate different things, but then you can also figure out ways to customize it so there might be different fields or things like that for each of those. That's a pretty good example there because it's something that we probably all are doing anyway, but they're all very similar. So why reinvent the wheel 4 different ways when you could say, well, let's make the whole car. So consistency is a problem that a lot of us seem to have when we're implementing our systems. Put simply here, data should live once. It sounds silly to have to say that, but data should be consistent across your systems in value, shape, and size. So value is one that we think about a lot. We want our data to be consistent. If we look up a customer in one area, their email address and things should be the same in different areas. If we're copying or storing that data in a different aspect or a different form, we want that value to be the same because we don't want it to be wrong. If their name updates one place, it should update everywhere. That's one that's easy to get across. But when I say shape and size, what I also mean is the format of it, or even things that are kind of silly if you have the access to this, is like the number of characters. Where this comes back to bite us a lot is if our systems let us specify the length of a different thing. So for example, if we have our service catalog, it's beautiful, we love it. In one area, we make the field hold 100 characters because we have really long service names. But then the next area, we only make it 50 characters. If we have a really long service name, it might actually get cut off there. That sounds silly to have to think about, but if you don't think about this stuff from the beginning, you can end up with some really weird anomalies as things go on. So my advice here is to try and look up, join, or query data, whatever types of things you can, as best you can, whatever your system allows. It's hard to offer specific advice because every vendor tends to handle this differently, but in my experience, every vendor does allow ways to do this with different solutions. So rather than copying data and then storing it, try to make things through relationships or other aspects of your tools, because copying data can mean that it won't get updated everywhere. And that can start to get really dicey once you're doing reporting or trying to get those, monthly or quarterly KPIs and metrics out there, and you realize that things don't quite look as right as they should. So on the concept of things like types, when we think about a type, every system, again, is going to be a little bit different, but this is kind of the basics of what those data can hold. So when you think about a text type or a string type, that's words, paragraphs, sentences, anywhere that you're going to be using text. Sometimes you can store numbers and things inside of there. That can be fine. And then we talk about things like numbers and integers, and those are numbers. You can have decimals and things. Sometimes the programs let us specify if something is a whole number or a decimal. Then there's logical or Boolean fields. You don't see a lot of vendors use the word Boolean, but that is a very coding, and that's true or false. And then there's usually date fields. These are the common ones I've seen across a lot of vendors, but using the right ones at the right time is really important. Theoretically, with a lot of these programs, we could make everything a text field. Every single thing could be stored as text. But then once we start to get into reporting or comparisons, if we're not using those fields appropriately, it can slow things down or make things more difficult, especially if once we get things exported out into report formats, it can start to get dicey and really difficult to do things. If you're using the appropriate field type or data type in your programs, it's going to allow for a lot more optimized querying or retrieving of that data. And also it can help protect you when things start to get really weird. If you store your employee IDs as a number, because they're all numbers, but then somehow your employee IDs get letters added to them because you've run out of numbers, then you'd have to figure out changing your data type. Or the opposite type of thing can also be true. So there might be some people with coding backgrounds that are like, these aren't data types I've ever heard of. There's more data types there with floats and longs and things like that. I've yet to see a vendor implement things like that. So if you focus on these main ones and knowing when to use them, that's going to go a long way for you. So a big thing in the coding world that they teach every single one of those computer science students in university is this thing called this SDLC, the Software Development Lifecycle. We have a lot of different things like that when we're talking about IT service management or ITIL, lots of functions and processes. But in SDLC, there's some really nice phases to think about that almost inform a lot of these modern paradigms that we're using in the service management world. So the phases in the SDLC are planning, into analysis, then design, then implementation, then testing and integration, then maintenance. It's kind of nice, it's kind of simple, but the idea is you plan what you're going to do, you make sure it meets the requirements, you go into a full design, you implement that design, you test it and have people accept it, and then you account for maintenance. What does this look like? What improvements need to be made over time? And that's kind of a nice way to think about some of the things when we're using a no-code environment. Just because these are coding concepts doesn't mean that you can't use them. So if you think about all these different phases and how you could approach them, the real summary here is try to plan out features. I think it's really common with our no-code environments because they enable rapid development or getting things out there working really quickly. We tend to just build, and we release things constantly, which sounds really cool in theory, but in practice, it means we're probably not documenting things as much as we could, and we also probably aren't doing some of that planning that I've been mentioning already. One of the big problems with that is we can end up making duplicate features, getting away from that dry concept, and really just making things hard to support over time. That supportability is a big aspect of why you want to do this structured planning. There's the aspects where you want to make sure that you're addressing the exact needs of your users, and there's a lot of things you can do here with like design thinking, user empathy, planning things out so that you're making sure that you're getting the right things. But from the pure SDLC aspect, it's really about making sure that you're not going to have to keep redoing the work that you're doing. So this is a weird one to mention, but it's very similar to the last one. But safety first, meaning just because you can doesn't mean you should. A lot of times, because these tools allow us to do these really complex things really quickly, we might not always be accounting for the security of things that are happening. Security and compliance are really important considerations. You have local compliance laws or rules or things that are applicable to you about personal identifiable information or medical records and things like that. As we use these systems and have access to them, especially in higher ed, there's a lot of gray areas where we're accessing this information. We might have a service management platform or a ticketing system that hooks into an information system where we have access to student, faculty, and staff records, and then we might be transforming those records and having things about where they live or other personal information. And because we have this data, we might be doing all sorts of things. We say, oh, we need to make a way for them to update their address in this system, but there isn't really a self-service in the ERP, but because our tool connects to the ERP, we could just show that data. So you've all of a sudden made a feature where a user can list their address and then confirm if it's correct and then update it. Sounds really cool, sounds really simple. But in doing so, what if you didn't secure it the best you could? What if you didn't consider security and somebody finds a way to look up anybody's address? Well, now that's a data breach, and we probably don't want to go down that road. So I put this here because in a coding world, usually these are concepts, I mean, people can make these same mistakes, but these are things that people usually account for from the beginning. But in a low code or no code environment, because you're clicking boxes in an editor or dragging and dropping things, it can be really quick to make a big oopsie. And then this last concept that I want to cover is one called refactoring. Refactoring is something that the low code and no code environment can benefit from just as much as the full coding environments. So refactoring means going back and improving. When we look at service management and ITSM, ITIL, all these things, continual process improvement is driven into us at the core. So we say we always want to make our services better. We want to figure out how we're offering things. We want to improve them. It's a living document. Nothing is written and then stopped. Makes perfect sense. In coding, when we say we refactor it, basically we're saying we've learned a lot of stuff as we've done these projects. Our skills have gotten better. We should look back at the old things we built occasionally and try and improve them. So I think this aligns very nicely with those ITSM concepts. If we look at our no-code environments, if we think about right at the beginning of our implementation of a system, we probably built a lot of things. It's rare in my experience for people to go back and check in on those. I don't often see a lot of people coming up and saying, hey, this form I built in my first week of having this awesome platform probably isn't as good as the ones that I built last week. So it does take some, self-recognition and awareness to say, maybe I can fix this or make it better. But the things that you've learned over time really can help you improve some of the features that you built in the beginning. And setting aside some time to go back and refactor those features is really useful. The benefits there are not only in a better and more consistent experience for your users and employees that are using the tools, but it's also because you've done some better things there. Some things might be more efficient, some things might look better. The reason to go back and do these is for that supportability and maintainability. If you've started changing how you do things more recently because you've gotten better, and somebody has to take over the system, let's say all of a sudden you come up with a ton of money and you can finally hire those employees that you've been looking for, they're not going to know that your older stuff is done differently than your newer stuff. And you don't really want to have to make a document that says, well, anything built before March is bad, and anything that I've built recently is awesome. Going back and applying these concepts can be really helpful for you. This is the final note I'll say here, and it's contradictory to the concept of this, but it is very beneficial to learn a little bit of code. When I say learn a little bit of code, I don't mean you have to go out there and learn C or Java or any of these things. What I mean is a lot of these tools become more powerful when you use the connectors they've built in. A lot of the tools on the market allow you to use REST APIs or SQL for querying or adding new data into it. A lot of them also allow you to work with structured data like XML, JSON, or CSVs for importing or manipulating data from other sources. This is a really important thing to consider at least learning a little bit about, because you can make your systems even cooler than they already are. If you're using these no-code environments, there's a lot you can do, but if you start to be able to integrate other systems, I mentioned earlier a lot of us integrate to our ERPs, but we probably have a ton of other tools that we would love to be able to play with. I know many of us have moved to Office 365 and Microsoft Teams and things like that. They all have APIs. So if you can say, ooh, I can get data from there, we can save conversation histories from our service desk into the tickets. Those are cool little integrations you can start to build yourself if you familiarize yourself with a few of these things. A lot of them have editors and windows and things that'll help you do these things on your tools, but just getting to know some of these is very helpful, and it makes you look awesome as you release these really complex features that didn't take too much work. So in review, we talked about immutability, which is making sure that our data is the appropriate one and isn't going to change and break everything. Don't repeat yourself. Stay consistent with your data across everything you're building. Make sure you know what data types to use. Plan everything in advance, especially in part of that planning, make sure that you're including security. Don't be afraid to go back and refactor, and then experiment with at least a little bit of code and you'll go far. With that, I want to thank you all so much for your time. If you ever want to connect with me, I can be found on Twitter at Chagnon, that's a 0 there, because I like to think I'm cool, or you can email me at cjchagnon@wpi.edu.
That's fantastic. Thanks for that, Chris. This is a little bit of a different presentation to what